Hello and again welcome to our channel with Astro, and here I'm Suraj with a new series on a physics topic which is the classical mechanics and generally the Lagrangian and the Hamiltonian mechanics. So in the past few lectures we have discussed about the quantum mechanics, but yes, the quantum mechanics lecture will continue. But today we're going to start a new lecture series on the classical mechanics, which is the Lagrangian mechanics, and what we're going to study is that about the basics of the Lagrangian mechanics and the importance of the generalized coordinates in the Lagrangian mechanics. Then finally the Lagrange equation. So this is basically the Lagrangian mechanics topic that we are going to study in the next 3 to 4 videos, and after this the Hamiltonian principle we are going to study. So let's start our today's video, and today is only the basics of the Lagrangian mechanics so that you can understand when we move to the higher level of the Lagrangian mechanics. So let's start our video. So basically, the Lagrangian mechanics is an alternative form of the Newtonian mechanics. It means whatever you study in the Newtonian mechanics, we are also going to do the numerical problems same in the Lagrangian mechanics, but the steps are different. There is a different method. The main difference is that in this particular Lagrangian mechanics, there are no concept of any of the vector quantities, no concept of vectors. There are no vectors in this. But the Newtonian mechanics is heavily dependent upon the vectors. Like you have to know about the force, momentum. But in the Lagrangian mechanics, there is no need of any type of the vector quantities. What you have to know is only about some of the generalized coordinates and a bit more about the systems, like it's the potential energy and the kinetic energy. If you know about this, then there is a very easy thing to describe all of the particular motions of the system. And that's the way Lagrangian mechanics simplifies various types of the problems that are very complex in the Newtonian mechanics. Like to find out the tensions in the strings when the two masses, like the pulley system like this. Suppose that there is a pulley which is a fixed pulley, and I'm assuming that pulley is massless, and in many cases pulley is massless, which reduces the complexities. But when you study the advanced classical mechanics, which I will also cover, you will see that what happens when the pulley is also has mass, how we can now go on the equations. Okay, so now you can see that here there is a tension in the string upward, and there is an mg force acting downward. And generally this is the way we can derive out the tensions in the string. But there is also another way. Using the Lagrangian mechanics, we can define the tensions in the strings, and which we will study in the applications of the Lagrangian mechanics. But for now, let's start the basics of the Lagrangian mechanics. So first of all, in Lagrangian mechanics, apart from the Cartesian coordinates, so in the Cartesian, what are the Cartesian coordinates? So generally the coordinates that we study in the general mechanics, which is the Newtonian mechanics, x, y, and z. Okay, x, y, and z axis generally we study, and to describe any of the particular motion of any of the particle, we uses the coordinates. So let's say I have drawn a coordinate system here to understand it very easily. Suppose that the particle is here, so what we see that we describe it by a position vector, ri, let's say, by a position vector ri. This is the x-axis and this is the y-axis. So generally we uses this to govern this, where the position vector can be anything. Position vector, we can write out the position vector. We can write out the position vector as the xi cap plus yj cap. Okay, remember here I is the subscript, and here I cap is the unit vector that is used to denote the directions in the x and the y axis generally. Okay, so this is the position vector. This is what we study generally in the Newtonian mechanics, and heavenly it is dependent in the Newtonian mechanics dependent upon these types of things. But in Lagrangian mechanics, there is an thing which is the different from the coordinates, what we call the generalized coordinate. Okay, generally generalized coordinate. So what is this? What is this particular generalized coordinate? Now we are entering into the Lagrangian mechanics. So first of all, to understand it, you have to understand that some of the basic terms. First of all, in generalized coordinates, you have to, some of the basic terms which I will introduce is the degree of freedom. Okay, so what this is? So degree of freedom can be thought as the possible ways the particle can do a motion. So the possible directions the particle can do a motion is called the degree of freedom. And what is the formula for the degree of freedom? So degree of freedom is equals to the 3n. And what is here n? N is the number of particles. So suppose that there are one particles. Suppose that there is one particle. Am I assuming that there is an x, y, and z axis? X, y, and z axis, let's say here. Okay. So now here the degree of freedom for the single particle is 3n. And it's a very simple, obvious that yes, particle can do a motion along x-axis, along y-axis, and along z-axis. But what will happen if there are two particles? So if there are two particles in a system, then it is equals to the 6th degree of freedom. And yes, this is obvious that it can now rotate also on its axis in the different directions. And that's why the degree of freedom increases. If there isn't two particles, I'm describing only for the one particle, this can only move there, there, and there. But if there is a system of two particles, so let's draw here, if there is a system of two particles, then the degree of freedom, as the equation is governing, is equals to the 3. And that is obvious. Yes, suppose that there are two particles that are connected with each other, and now what they can do is that they can also rotate on the different axes, and the degree of freedom is equals to the 6. They can move along the x-axis, y-axis, and z-axis, and also do the rotational motion on the different axes. And that's how there is a 6th degree of freedom for the two particles. And for 3 particles there is 9, for 4 particles is 12, and so on. This is the meaning of the degree of freedom. Next thing is the constraint. Next thing that you have to understand is about the constraints. This is also very important. Basics is also dependent upon the constraint. So what is constraint, first of all? So in Newtonian mechanics, I'm pretty sure that you have familiar with these types of the topics, that what is constraint motion. So let's recap this. So what do you mean by the constraint? So constraint can be thought as the restriction in the motion of an object. Restriction. So suppose let's suppose that an object is moving in a circular motion about a fixed radius like this. I'm just drawing. Okay. Suppose that an object is moving like this. So there is a constraint here. Yes, there is a constraint that the particle cannot move. It's a move in a fixed radius, which is a. If we suppose that it is in a fixed radius, and it cannot move outward this. It has to move only in a particular fixed radii, which is a. And that is the constraint in the motion, that it cannot move outward and cannot move outward any of the a. It can only have a fixed particular distance from its point here, and that is the a. And there is a constraint, and there is a force of constraint that is keeping that object in that motion. So the force that is keeping the object in a fixed rigid motion is called the force of constraint. And here the force of constraint is the tension force. Tension force is just keeping the particular object in this particular circular motion so that it cannot escape through that particular motion. Now you understand that what is constraint? Constraint is nothing but the restriction in the motion. Restriction in the motion is defined as the constraints. And as you can see here, the particle cannot move from a particular distance a. It has to be in a particular distance a from the axis, and it cannot move outward or inward. And the force that is keeping that particular constraint is called the force of constraint. And in the example of the circular motion, the force of constraint is what? The tension in the string. The tension in the string is responsible for keeping the object in that circular motion, in that constraint motion. So that circular motion is also an example of an constraint motion. I hope that you understand the constraint motion. Okay. So what we have studied about the degree of freedom. It means in how many possible ways a particle can propagate and do the motions, and it depended upon the number of particles. If you increase the number of particles, the degree of freedom also increases. And then we study about the constraint. Constraint can be thought as a restriction in the motion. It means suppose that you can also visualize that an object can only move in the y-axis, not in the z-axis. So there is a different types of the force that is keeping this constraint, and that's the force of constraint. And the circular motion is the best visualizations of the constraint motion. Now moving to the generalized coordinate. What is generalized coordinate? So it is a same as the coordinate that we study. No, it is different from this. How? So let's see. So we have studied basically about the coordinates x, y, and z axis. Okay. But when we introduce the constraint to that particular motion, suppose that in the x direction we do the constraint, it means particle cannot move in the x axis, x direction. It means there is only motion in which particle can only move in the y and the z axis. Okay, and that is called the what we generalized coordinate. So generalized coordinate, let denoted by the q. Q is equals to the 3n minus k. Okay, so 3n is what? It is the degree of freedom minus here k, and what is k? K is the constraint in the direction of the motion. So suppose that a particle, a single particle is there and it has constraint in the one direction. It has constraint in the one direction. Let's say in x direction it has constraint. There is a draw on another axis here, x, y, and z axis as well here. Here, suppose that the particle has constraint in the x-axis. It means it cannot move in the x-axis, only y and the z-axis. Then q is equals to the 3 minus 1, which is q is equals to the 2. And this is called the generalized coordinate. Now listen carefully. Generalized coordinate is the independent coordinates that is used to describe the motion of an object. Remember that it is an independent from each other. It is not dependent upon each other, and that is called the generalized coordinate. The independent coordinates used to describe the motion is called the generalized coordinate because it simplifies the various types of the calculations in the Lagrangian mechanics. That why we uses the generalized coordinate. So suppose that an object moving the circular motion here, just like here, draw a circle. Okay, circle is terrible. Suppose that we made a circle here, and suppose object is moving here, so there is a constraint in the constraint here in the motion. So here what is the generalized coordinate? So as you can see here, there is only one generalized coordinate that is sufficient for explaining all of the motions of the particle, which is here the angle theta. Here the angle theta. So let's draw in a bigger picture and to understand it. So this is a circle, and if a particle is moving in that particular circular motion, so the only coordinate that we can do to describe the motion of an object which is the independent of any other things like the x and y. In this particular scenario, as you can see here, the theta angle is not dependent upon the x and the y. It means it is independent and it is sufficient for explaining all of the motions of an object. So in the case of circular motion, the generalized coordinate is theta. Generalized coordinate can be anything, any group of, it can be the group of Cartesian coordinates, it can be a group of polar coordinates, and it can be a group of cylindrical coordinates. It can be a group of any of the coordinates, but there is a condition that they have to be independent. In this condition, it is a condition you have to be independent of each other, not dependent upon each other. They have to be independent upon each other, not dependent upon each other. And that is the true condition that is used to do in the constraint and the generalized coordinate. So I hope that you understand that what is the meaning of the generalized coordinate, and what is the meaning of the constraints in a motion, what is the meaning of the coordinates, Lagrangian mechanics and generalized coordinates, and the degree of freedom mainly. So degree of freedom, I hope that you understand all of the things. So let's recap it. So first of all, we deal with the Lagrangian mechanics. So it is basically an alternative of the Newtonian mechanics that help us to visualize various types of the situations which are very complex in the Newtonian mechanics in an easy way. Generally, the equilibrium system conditions are very useful when we do with the Lagrangian mechanics. Then we study about the basic terminologies in the Lagrangian mechanics, which is the generalized coordinate. How the generalized coordinate is different from the Cartesian coordinates, because generalized coordinates are independent of each other, and they are sufficient for explaining all of the motions of an object. And next thing is the degree of freedom. What is degree of freedom? It can be the any possible ways a particle can propagate. It is called the degree of freedom. So for one particle it is 3, and for two particle it is 6, and so on. And here I have given the formula of the degree of freedom. Next thing we study about the constraint. What is constraint? So constraint can be thought as the restriction in the motion of an object. Like in the circular motion, there is a restriction that particle cannot have the radius more than a. It has to move in a fixed radius a, and that is a constraint in the circular motion. And the force that keeps that particular constraint is called the force of constraint. And in the case of this particular circular motion, I have told you that in this case that tension is the constraint here. It means tension is what the constraint, force of constraint. Tension is called the force of constraint, FOC, because it is the force that keep the objects in the circular motion. Then we study about the generalized coordinates. The number of independent coordinates that are used to describe the motion of an object is called the generalized coordinate. And then we study that what is generalized coordinates in context of the circular motion, which is theta angle, which is independent upon the x and the y axis. Because in the circular motion, particle have only restricted value of the x and y. It cannot move beyond the x and y. And here theta angle is also independent upon x and y, and that's why it is very useful to describe this theta as in our generalized coordinate. It can be anything. I have told you that it can be anything, and you have to choose this. How you choose this generalized coordinate? So applying this particular formula, you can choose the generalized coordinate. First of all, find the degree of freedom and the constraint, and then subtract each other, and then you get the number of the generalized coordinates, number of independent coordinates that can be used to describe the motion. I hope that you understand all of the things, and if you do not understand, you can write the comments. I will make another video on explaining it in a very detailed manner also, and from the basics, which is from the Newtonian perspective, I will also explain this. So in the next video, what we are going to study is about the principle of virtual work, which is the very important topic also, D'Alembert's principle, and finally the Lagrange equation. I hope that you understand all of that particular things. So thank you for watching my video.